Okay, so in last class, okay, you already learned, okay, we already see the examples, okay, using the CTC mode to program the timer one. Okay, now we are going to use the second method, which is a normal mode, okay, in order to program timer one. Okay, so again, okay, there are few steps that you need to remember, okay, in order to what we call here, to program timer one by using a normal mode. Okay, first thing first, what you're going to do is you need to calculate what is your TCNT, which is the first step. You need to load your TCNT. After you load the TCNT, then you need to do some setting to your TCCR, and then after that, monitor your overflow flags, stop your timer, and reset your overflow flags. Okay, so we using the same examples. Okay, so this is okay, which is you need to rewrite examples 930 using TOV1 flags. Means that this is TOV1 flag is actually by using the normal mode or overflow methods. Okay, so let's look at the calculation that we done earlier. Okay, so this is the calculation. Okay, so from here we know that the estate is 8 megahertz. Okay, the delay that you're going to create is 1 millisecond, and by using this thing here, okay, without using any prescale, then you will get the period, and after that, okay, we calculate the count. Okay, so the total count that you need in order to generate a 1 millisecond delay is 8,000 times. Okay, then after that, after we apply this equation here, okay, the third equation that you need to do is for the normal mode. Okay, for the normal mode is TCNT equal to F F F F minus count plus 1. So this is the how to calculate. Okay, this is the formula how to calculate the TCNT value. All right. So you press the calculator, you have already have the count. Count is 8,000. Okay. Minus with this value, FFFF. Okay. Since this is a decimal. Okay. So you need to convert this value here to hexadecimal. And then after that, you plus with 1. Okay. So the value that you will get here is 55,536, which is equivalent to E0 C0. So this is the value that you're going to load to TCNT by using normal mode. Okay, so now we are going to do what we call here the programming. Okay, for the normal mode. Okay, which is okay. We started with create the subroutine of this delay here. All right, so since this is a 1 millisecond delay, so you just simply write down the delay name. Okay, void delay 1ms or any other name that you're going to use. Okay, it up to you. Okay, the names of this delay here, the subroutine. Okay, and then you start with the delay writing here down here. Okay, so the first step, what is the first step? Okay, the first step using the normal mode is you're going to load the TCNT. All right, since this is a timer one, okay, timer one consists of a 16-bit register. So your TCNT also have 16-bit, means that you need to divide it to 2 bytes. One is a lower byte and the other one is a higher byte. So you have, since this is a timer one, so you have a TCNT 1L for lower and TCNT1H for higher byte. Okay, now we're going to find out what are the values that we need to put in these registers here. Okay, so according to the calculation, okay, that we did earlier, so this is the TCNT value that you're going to put here. All right, so since this one here, okay, since this is a 60-bit, okay, you can divide it to 2 byte. So this is go to low byte, and this one, this number here go to high byte. Okay, so the value that you're going to put to TCT1L, which is lower byte, is 0xC0. Okay, and then TCNT1H, so this is your higher byte, so this is 0xE0. So this is the first step in which you load the TCNT value. What is the TCNT value? E0C0. Okay. Next, second step. Okay, what is the second step here? The second step is you're going to set your TCCR register. Okay, again, for the timer one, there are two TCCR register that you need to set. One at TCCR1A, and the second one here is TCCR1B. Okay, so by default, the value for TCCR1A is 0. Okay, we already looked at this TCCR setting earlier in the last week. Okay, so by default, the value for TCCR1A, okay, you put it 0, and TCCR1B according to your TCCR1B setting lah. Okay, so this is your TCCR1B. Okay, so the bit that you need to set is this bit here, right? Bit 3 and bit 4. So this will determine the mode that you're going to use. And next is these 3 bits, okay, which is bit 0, 1, and 2. So this is to determine the prescale option. Okay, since in this example here, okay, we are not using any prescale, so the setting for this last 3 bit is 0, 0, 1. What about this 3 bit? What is the setting that you need to use in order to use a normal mode? What is the value that you're going to put on bit 3 and bit 4? Okay, so 0B, 0, 0, 0. Okay, so what would be the value here for normal mode? Anyone? Okay, so you refer back to this table here, all right? So for this setting here, okay, the setting for the mode, okay, for normal you need to put 0, 0 for normal, and for the prescale, without any prescale, the value will be 0, 0, 1. Okay, so so this is the value that you're going to put to your TCCR1B, which is 0, 0, 0, 0. 0, 0, all right, so this is a normal mode, and 0, 0, 1. Okay, so you know that this is normal mode without prescale. Okay, so timer 1, normal mode, no prescale. Okay, next, third step, step number 3. What are you going to do for the step number 3? Step number 3 is we need to monitor the overflow flags. Okay, so what is the overflow flag that you're going to monitor? Okay, so in this example, okay, we are going to monitor TOV1 flags. Okay, why TOV1, not TOV0 or TOV2? Because it is a timer 1. Okay, so the overflow flag, okay, the CPU need to monitor is TOV1. Okay, so you just simply write down, this is how to monitor while TIFR, okay, and then end with, okay, put 1 to TOV1, oh sorry, TOV1, is it equal with 0? If yes, it will keep repeating, okay, it will keep monitoring. And when no, if the TOV1 is 1, so what happened here? Then, okay, you're going to, okay, so this is the third step. And step number 4, you are going to stop the timer. How to stop the timer? Okay, put 0 to TCCR1A and TCCR1B. Okay, so just simply TCCR1A equal to 0 and TCCR1B also you put it 0. So this is step number 4. Okay, stop timer. And after you stop the timer, then you need to clear the TOV1 flags. How to clear your TOV1? Okay, simply put 1 to your TOV1 location, okay, or TOV1 flags, okay, by putting TIFR equal to put 1 to TOV1. So this is step number 5. Okay, so this is the what we call here, okay, the program, okay, in which you use a timer 1 normal mode in without a prescale in order to generate a delay of 1 millisecond. Okay, the actual speed is 8 megahertz. Okay, so this is the coding lah. Okay, so you can see here. Okay, down here. So this is the coding for delay 1 millisecond, and this is the main program in order to do a toggle. Okay, which is you're going to toggle port B pin number 5. Okay, how many second? 1 millisecond each of logic 0 and logic 1. Okay, any question for timer 1 programming? Okay, we already seen the timer 1 programming by using a normal mode and timer 1 programming by using a CTC mode. Any question, guys?
No, doctor.
Okay, if no question, then we go to the next slide. Okay, which is timer 1 generate a large delay. Okay, so to generate a large delay by using prescale. Okay, again, in order to generate a large delay, you can use the prescale option. Okay, so the size of the time delay will depend on 2 factors. Okay, one is your crystal frequency or your CPU speed, and the second one is the timer. Okay, how the size of the TCNT, is it a 16-bit or 8-bit? All right, so and then there is another way, okay, in order to generate a large delay, which is by using prescale. Okay, so use the prescale option in TCCR1B to increase the delay by reducing the period. Okay, so the prescale option allows us to divide the instructions clock by factor 864 256 1024. So this is the prescale option available in timer 1. Okay, so the way you're going to do the programming in for the prescale is similar to timer 0 and timer 2 programming. Okay, which is you need to divide the frequency or your actual speed by the prescale, and after that, okay, you get the frequency for the after the prescaler. Okay, then get the what we call here the period. Once you already get the period, then you can calculate the count, okay, by using the delay equation, and after that you can simply calculate the TCNT or the OCR value. Okay, so that is for the timer 1 programming. Okay, so now we are moving to counter. Okay, a part of using a timer to generate a delay, this timer also can use to count an event. Okay, so now we are going to look at another function of timer, which is to count a certain event, or we call it as a counter. Okay, so the AVR timer can also use to count or detect and measure the time event happening outside the AVR. Okay, so a part of you using the clock inside the AVR, so you can also detect the clock outside the AVR, which is you can use the external oscillator, or you can simply use a switch as your clock pass. Okay, so when the timer is used as a timer, okay, the AVR crystal is used as the source of the frequency. But when the timer is used as a counter, the pulse outside the AVR that will increment the TCNT value. Okay, so in counter mode, registers such TCCR, OCR, TCNT are the same as for timer discussed previously. Okay, so for the counter mode, okay, so this register of, okay, so you are going to use this register, okay, according to method that you're going to use. If you're going to use the overflow method, and then you use the, oh, sorry, for TCCR, sorry, for the counter, you can use the, wait, for the counter, we simply use the, okay, you can use either normal mode or CTC mode as well. All right, so before we go more detail on the counter programming, okay, so let's look at the, okay, where you're going to fit in the clock or the pulse in order to generate a clock for the counter sequence. Okay, so we need to recall back to this bit here inside of the TCCR, which is decide the source of the clock and prescale use. Okay, so you have the TCCR. Let's look. Okay, go back to our TCCR 0. Okay, so this is your TCCR 0. Okay, in which these 3 bits here, okay, the last 3 bits here is used as a prescaler. And at the same time, it used to select the counter. Okay, so when this 3 bit, okay, the value of this 3 bit is from 000 or 001. Okay, so until 101 means that, okay, the timer get the pulse from the crystal oscillator, which is you're going to generate a delay. Okay, either using no prescale or with a prescale. Okay, when this value here, which is from 110, okay, when you put 110 or 111 to this bit here, so what happened here is now you use this timer 0, okay, as a counter. Okay, so when this bit, okay, you put value bit from 110 and 111. So what happens here? Timer is used as a counter and get the pulse from source outside the AVR chip. Okay, so you going, okay, so the microP will take the clock pulse or okay, or the clock source outside from the AVR chip, not using the CPU speed. Okay, so when this, okay, when this bit, okay, you put 110 or 111, okay, what happened here is the TCNT 0 counter count up as pulse feed from pin T0, okay, which is this pin T0 is used for timer or counter 0 external clock input. Okay, so we recall back, okay, so this is the timer 0. Okay, so this timer 0, okay, and then this is the TCCR, okay, which is on the last 3 bit of the TCCR. Okay, you have the selector here. Okay, you have three selector, which is CS02 until CS00. Okay, so this selector will determine, okay, what is, okay, the clock source that will fit to this TCNT. Okay, this is the TCNT, and then this is the clock source. Okay, either using the external as a clock source or the T0, which is the external or pulse from the outside of the CPU as the clock source. Okay, so now, okay, we are going to focus on this part here. Okay, for when you put bit 3 either 110 or 111, which is you're going to make your timer as the counter. Okay, so now we are looking. Okay, since this is coming from outside, so there is one pin that you need to put the input. Okay, so that it become the clock input, the clock source. Okay, where is the T0? So actually the T0 located at port B pin number 0. So this is another function, okay, another features or another function for port B pin number 0, which is it become your T0, the clock input, okay, or the pulse, okay, the external clock or pulse for timer. Okay, so this one here. Okay, so in order to use a counter, so make sure that the P0 is connected either to the oscillator, okay, external oscillator, or you can put to the switches. Okay, so every time the switch is pressed, then the counter, the TCNT value will increase. Okay, so this is your Omega 32 pin out. Okay, so this is where the T0 located. Okay, at port B pin number 0. Okay, so in Omega 32, okay, T0 is alternative function of port B pin number 0. Okay, so when this 3 bit inside of TCCR 0 is given this value, either 110 or 111, pin T0 will provide the clock pass and counter count up after each clock pass coming from T0 pin. Okay, so this is your PB0. Okay, so this PB0 is actually your T0, and then you will going to give the clock pass. Okay, this clock pass is either coming from the external or you can put it as a switches. Okay, so every time you press the switch, okay, it will provide this square wave lah. Okay, so let's look at these examples. Okay, how this T0 works. Okay, you're going to find the value of TCCR0 if you want to program timer 0 as a normal mode counter. Okay, again, as I mentioned, for counter, okay, it will have two types of mode here. Either you can use it as a normal mode, which is using an overflow method, ataupun you can use a CTC method. Okay, so in this example 934, okay, you're going to find out the settings, okay, for timer 0, which is you're going to use the normal mode counter. Okay, use an external clock for the clock source, and the TCNT will increment on the positive edge trigger. Okay, so now, okay, what you're going to do here is, okay, we're looking back at this TCCR register. Where is the TCCR register? TCCR, D is TIFR. Okay, so this is a TCCR register. Okay, you see here, you have two combination of input, either 110 and 111. Okay, so this is the things, okay, that will trigger, okay, or that will increase the TCNT value, either, okay, you're going to use a falling edge trigger or rising edge trigger. Okay, so if you put a 110, what happened here is external clock source on T0 pin, means that, okay, you put the external clock to your T0 and the TCNT value will increase, okay, will increase on falling edge. Okay, so every falling edge, TCNT plus plus, okay, will increase. Okay, while if you put 1111, what happened here is, okay, again, okay, the clock source is coming from T0 pin, but the TCNT only increase, okay, only increase on the rising edge. Okay, so this one here, TCNT only increase every rising edge. Okay, so this setting here will determine either the TCNT increase on rising or falling edge. Okay, so we go back here. Okay, so the setting here, okay, when you put 110 to TCCR, what happened? This one is a falling edge, okay, and then the TCNT will increment, and when you put 111, okay, every rising edge, then the TCNT will increment. Okay, so now we're looking back at this example 934. Okay, timer 0, normal mode, using external clock for the clock source and increment on the positive edge. Okay, so you're going to find out what is the setting that you're going to put here. Okay, so this is your TCCR0. Okay, and then you're going to find out what is the value that you're going to put here. Okay, so recall back, this is the TCCR0 registers. Okay, and the bit that you need to emphasize, okay, you need to set is, or do some setting is bit 6 and bit 3. Okay, so this will determine the mode, and this last 3 bit. Okay, since this is a normal mode, all right, so the value that we're going to put here is 0 0. Okay, for normal mode. Okay, and then, okay, external clock source and increment on positive edge means that every positive edge trigger, it will increment the TCNT value. So the value that you need to put on this last three bit is 1 1 1. Okay, so here the value here is 0 0 0 0 0 1 1 1. Okay, so you know that this is a normal mode. Okay, sorry, not this bit. Okay, this bit here. Okay, normal mode and rising edge. Okay, so the TCNT will increment every rising edge trigger. Okay, so let's look at another examples. Okay, so assume that 1 Hz clock pulse is fed into pin T0. Okay, so you have the external clock source. Okay, which is 1 Hz. Okay, the speed of the external clock is 1 Hz, and it is fed into pin T0. Okay, so this is PB0. Okay, and then you have a 1 clock. Okay, so this is your external Esther, which that have a frequency of 1 Hz. Okay, so write a program for counter 0 in a normal mode to count the pass on the falling edge. Okay, so you're going to use a counter 0. Okay, normal mode. Okay, and then falling edge. And display the state of the TCNT0 count on port C. Okay, so this is your port C. You have a port C. So port C, now you're going to display. Okay, this port C is 8-bit. You're going to display the TCNT value. Okay, so what are you going to do? Okay, so first, okay, so this is how we're going to write down in assembly language lah. Of course, we are going to write down in C programming. Okay, so what you're going to do here is first, okay, so we just, okay, so started with the include the standard file. So include avr, okay, /io.h, okay, and then you start with main program. Okay, so main program. Okay, for the counter, okay, just to inform you, for the counter, you no need to initialize any subroutine. Okay, no need to define counter subroutine. Okay, compared to timer programming, delay programming, you need to initialize or define the delay subroutine. Okay, in between this including include file and your main program. Okay, so first, what you're going to do, since this one here, we have two port here, port C and port B. So what we're going to do, we need to initialize the port B and port C so that it become input and output port. Okay, so port C become output. Why output? Because you're going to display the TCNT value. Okay, so DDRC equal to OXFF. And what about your PB0? Okay, your PB0, you can simply make it as an input port. Why input? Because you're going to fed in, okay, this clock pulse to PB0. So DDRB equal to 0B11111110. Okay, and then after that, okay, after you initialize this one here, okay, so what are you going to do? Okay, we're going to start the setting. Okay, so now, right, okay, before we the first step, okay, is clear your TCNT. Right, because we are going to use a counter 0. Okay, so the TCNT will be TCNT 0 lah. Okay, TCNT 0 equal to 0. Okay, clear TCNT. Okay, once you clear the TCNT, then you do the setting. Okay, which is similar to the delay programming. Second is do some setting. Okay, so the setting for TCCR0 is 0-bit. Okay, what will be the value here? Since this is a normal mode, falling edge. So 0, 0, 0, 0, 0. What about a falling edge trigger? So falling edge is 1, 1, 0. Okay, and next, okay, after you do this one here, okay, then after that, what you're going to do is, okay, we can use the while loop. Open curly bracket and close curly bracket. And inside here, okay, so what you're going to do here is, okay, the third step, okay, you need to, okay, since this is a normal mode, then what we're going to do, we need to monitor the TOV flags lah. Okay, so Y TIFR, okay, sorry, and with TOV0, okay, and is it equal with 0? And what happens if it equal with 0? Okay, so that will be another description down here lah. Okay, which is when the TOV0 still 0, so what you're going to do here is you're going to send out, okay, the TCNT content to port C. Okay, so you can simply write down, okay, port C equal to TCNT 0. Okay, what happens when the TOV0 now equal to 1, which is the overflow occurs? Okay, once the overflow occurs, what we're going to do is, so this step number 3, okay, step number 4. So what you're going to do, okay, next, we can stop the timer. Okay, so TIFR, sorry, not TIFR, that one is clear the TOV flags, okay. TCCR0 equal to 0, okay, you stop the counter, and then after that, okay, clear the timer. TIFR, okay, so this is step number 5. Okay, so this is what happened. Okay, this is the programming that you're going to write, okay, according to these examples. Okay, so this what we call here, okay, the TCNT, okay, this TCNT0 will increment every falling edge. Okay, so every falling edge of this clock input that are coming from PB0 pins. Okay, so this is how you're going to do the counter programming. Okay, any question up until here? Ada soalan tak? Okay, actually, okay, if you're going to do the counter, what we call here, okay, you're going to do this counter continuously, okay, you can simply put these two here inside of while loop. Okay, so you can put this setting, step 1 and step 2 inside of while loop if you're going to do the counter continuously or endlessly. Okay, which is it will count from 0 until 255, and then it goes back to 0 and count until 255. Okay, it will keep repeating. Okay, any question up until here? Okay, if no question, then we go to another examples. Okay, we have another example for the counter. Okay, so you are going to write a C program to toggle all the bit of port B continuous. No, not this one. Okay, so this one is C programming. Okay, 943. Okay, assuming that 1 Hz clock pulse is fed into pin T0, use TOV0 flag to extend timer 0 to a 16-bit counter and display the counter on port C and port D. Okay, so now previously we only count from 0 to 55 only. Okay, which is D is only a 8-bit counter. All right, so in this example, you're going to increase the content, okay, the counter, so that you can count from 0 to F, 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 F. So how to do that? Macam mana nak buat? Okay, to do that, we need to have 2 ports. Okay, okay. So the first port here, okay, which is consists of the TCNT0 value, and the second port here, D is big. Okay, which is D is a port C lah. For in this example, we use it as a port C, and the second port here will use to hold this value here. Okay, the another 8-bit value, because you're going to do a 60-bit counter. Previously only 8-bit, so at 8-bit you can directly use something like this. But now you're going to increase the counter from 8-bit to 60-bit. Okay, so you need to do some modification lah on this programming. Okay, so what you're going to do? Okay, first, similar lah. Okay, first you include this file. Okay, started with your main program, and then initialize your input-output port. Okay, since this one here, 16-bit, okay, because we're going to display the counter, okay, to port C and port D. So what you're going to do here is, okay, okay, so what we're going to do here is, all right, so now we need to initialize another port, which is DDR. This port D, DDRD sama dengan OX FF. Okay, so this one we store the lower byte of the 16-bit number, and DDRB will store the higher byte of 16-bit numbers. Okay, then started with this one here. Okay, TCNT equal to 0, and then TCCR 0. Okay, so in this dia kata, okay, it doesn't tell okay which falling edge or rising edge, so we using the same lah. Okay, the falling edge triggered, okay, so it's 110. Okay, so this is the setting because you're going to use a normal mode. Okay, and then we put 0B0000 for normal mode and 110. Okay, next. Okay, start with your while loop. Okay, while 1 equal to, and then under this while loop here, you make another while loop, which is to monitor the TOV0 flags. Okay, so while TIFR end with 1, okay, put to a TOV, is it equal to 0? If not, what happen is port C is equal to TCNT 0. Okay, so this port C will incremented from 0 until 255. Okay, which is 0 until FF. Okay, so this is what happened here. Okay, before that, okay, I'm going to clear the port D. Okay, so that the port D equal to 0. So now I put here port D sama dengan 0. Okay, so the initial value of port D is 0. So this is your port D, and this is your port C. Okay, so started with 0, 0, and this one here will counting from 0, 0 until FF. Okay, so what happened when FF? Okay, then this exit, okay, this while loop, okay, this monitoring loop will exit from, okay, from the loops, and then what you're going to do here is, okay, you stop the counting, okay, ataupun, okay, no need to stop the counting also can. Okay, if you stop the time counting, then this this thing here you need to put inside here lah. Okay, so next, okay, clear the TOV0 flags. Okay, once you clear the TOV0 flag and you put another instruction here or another code is port D sama dengan port D plus with 1. So what happened here? Now the port D will increment to 0, 1. And this thing, since it is inside the while loop, okay, it will keep looping. Okay, do again, counting from 0, 0 until FF. 1, this loop here is what we call here is false. Okay, which is the overflow occurs. What happened? Okay, then you stop the timer, clear the TOV flags, and increment the port D. So now the port D become 0, 2, and it will keep repeating, counting from 0, 0 until FF. Overflow occurs. What happened? Okay, it will stop the timer, clear the TOV, and increment the port D value. So this is how you're going to do the 16-bit timer. Okay, so this lower byte. Okay, so this lower byte will use, okay, will increment according to TCNT0 value, while the port D is increment after, okay, you exit this loop here. Okay. Okay, sekejap ya. Okay, Azari asking that can we initialize TCNT with another value, for instance, count from values 0A to FF? Yes, you can do that. Okay, how to do that? Okay, you just simply, okay, so this setting here, okay, step 1 and step 2, as I mentioned, you need to put inside of this while loop. Okay, so this while loop you need to put here lah. Okay. Okay, I just simply, okay, so these two you put inside here and make sure that TCNT0, okay, no need to initialize with 0. Okay, you're going to initialize with 0A. Okay, so TCNT0 equal to OX0A, and then do the setting, monitor the while loop, and when the overflow occurs, exit from this monitoring, stop the timer, okay, and clear the TOV flags, and then start the and then increment the port D. Okay, so this is the to answer Al-Zahri question. Okay, you can put any value. Okay, you can start with any value for your TCNT. Okay, but of course lah, for the counting, okay, we need to make sure that the TCNT0 is started with 0. So that is the basic counting lah, because we can counting from smaller number to higher number, which is from 0 until 255. Okay, so that is for the counter programming. Any question for the counter programming? If no question, okay, we are going to look at a few examples for the timer programming. Okay, which is this timer programming will be asked in your final exam. Okay, definitely asked in the final exam. Okay, so just to inform you that, okay, the final exam, okay, you have two section, two part for the final exam, okay, which is a part A, okay, and part B. Okay, part A is for the assembly language, while part B is C programming. Okay, and then the mark distribution for part A and part B is 50% each. All right, so the part A is assembly language. Okay, for the assembly language, okay, the question that will be asked is something like the first, what we already did in the test, which is you're going to have an analysis. Okay, do the analysis. Okay, given a program, okay, you need to figure out what is the outputs of the registers after you execute a certain program. Okay, that is an analysis of the program, and then you need to do some programming. Okay, which is given a question or given a problem. Okay, then based on that problem, you're going to do the programming. And satu lagi is a theoretical lah. Okay, theory. Okay, so this is only 5%. Okay, for the theory, and then you have an analysis and programming. Okay, for the part B, okay, which is a C programming. Okay, the topic that we'll cover here is, okay, the I/O programming, and then we have the interrupt programming and timer programming. Okay, and one more thing is ADC lah. And for this semester, ADC will not be asked in the final exam, so you only need to focus on these 3 chapters only: interrupt and timer. Definitely, this interrupt and timer will come out in your final exam. Okay, because for the I/O is actually a subset of interrupt and timer. Okay, every time you use an interrupt, then you need to know the I/O, how to perform the I/O. And if you use the timer elsewhere, you need to know how to program the I/O, which is you need to initialize the input-output port and how to send or what we call how to do a blinking sequence, all those things. Okay, you have an LED patterns, and then based on the LED patterns, okay, then you need to do the sum sequence, and then after that you have a delay. Okay, to display that sequence, you need to create a sum delay. Okay, so all these 3 things, okay, these 3 chapter will related one to another lah. Okay, in interrupt you also have a I/O. If the question is asked in timer, also you need to know some I/O programming. Okay, so now we are looking at this programming here. Okay, these examples. Where is it? Sekejap ya. I need to. Alright. Okay, this is another examples. Okay, given us. Okay, you're going to write a C program to toggle all the bit in port B continuously. Okay, again, you have a port B, and then you're going to toggle this port B continuously. Okay, means that you're going to do a sum. Okay, toggles means that you need to put, okay, first is creating a 0, and then after that creating a logic label 1. Okay, with some delay. Okay, use timer 0, normal mode, and no prescaler. Okay, assume that the X is 1 megahertz, and the delay that you're going to generate is 200 milliseconds. Okay, so how to do that? Okay, so it asking you to use a timer 0, normal mode. Okay, so no prescheduler ni, I skip this part here. Okay, to generate a delay. So you're going to generate a delay 200 milliseconds. Okay, with a 1 megahertz, timer 0, normal mode, and okay, you need to figure out what is the prescale option that you're going to use. Okay, so first, what you're going to do is, okay, we need to figure out, okay, since this is a 200 millisecond delay, okay, so we need to figure out what is the maximum delay that will be generated if no prescale is used. Okay, how to get a maximum delay? Okay, to get a maximum delay, what you're going to do here is you need to make sure that the TC and T equal to 0. Okay, because this is normal mode. Okay, to get a larger delay, okay, the maximum delay, okay, make sure that the TC and T is set at 0. Okay, you empty your water bottle and then you will get, this is all the delay that you can generate. Okay, since TC and T sama dengan kosong, so now you can know that, okay, since the TC and T sama dengan kosong, based on the equation number 3, TC and T equal to FF minus count plus 1, okay, and then count equal to FF, which is 255 plus with 1, and then you will get 256. Okay, so to have a maximum delay, okay, the count will have 256 times. Okay, so now what we're going to do next is, okay, we need to figure out lah, is it no prescale is enough in order to generate this 200 millisecond delay. Okay, so now this is a no prescale. Okay, we know that delay equal to, delay equal to T multiplied with count. Okay, we have count is 256. Okay, now we need to figure out what is T. Okay, since it given that, okay, the 1 megahertz. Okay, so the T with a no prescale is 1 microsecond, which is you can simply using this formula here. Okay, so T equal to 1 over F. Okay, and then FP, which is F prescale, equal to F divided by prescale. Okay, so next, what you're going to do, okay, and put it inside of this formula, and you will get 1 over F over P, which is equivalent to P over F. Okay, since no prescale means that the prescale value is 1 lah. Okay, so this is T actually sama dengan P over F 1 megahertz and multiply with 256. Okay, so with no prescale, what is the delay? Okay, maximum delay that you can generate. Okay, so simply put, okay, put in the formula 1 divided by 1 megahertz, and then darab dengan 256, and then you will, or sorry, not this one, 1 divided by 1 megahertz, and then darab dengan 256, and then you will get, okay, 256 microsecond. Is it able to generate a 200 millisecond? Not enough without a prescale. Okay, so without a prescale, the maximum delay that you can generate is only 256 microsecond. Okay, so next, what you're going to do? Okay, next we're going to use a prescale 8. Okay, put inside of this formula. So 8 divided by 1 megahertz darab dengan 256, and then you will get, what is the value? Anyone can please press the calculator. Okay, which is 2.048 millisecond. Okay, prescale 8 also not enough to generate 200 milliseconds. Okay, and then we increase the prescale. Okay, now why not we use the, okay, we have 8 and then 64. Is it timer 0? Okay, what is the prescale available for timer 0? Okay, we can refer back to the slide here. Timer 0. Where is the timer 0 prescaler? Okay, timer 0. Okay, so this is timer 0. Okay, you have 8, 64, 256, and 1024. Okay, you have 4 prescale to choose from. 8, 64, 256, and 1024. Okay, now we use the 64 and see whether 64 is enough to generate a 200 millisecond delay. Then we increase to 256, and lastly is prescale 1024. Okay, what 64? What is the delay, maximum delay that you will generate for 64? Okay, simply put it in the equation that we derived earlier. So this is the equation lah. All right, so make sure that you okay. So this is the equation here. P over F multiply with 256. Okay, 64 bahagi dengan 1 megahertz. And then you will get, okay, so this one of 16.384 millisecond. Okay, also not enough to generate 200 milliseconds. Okay, what about 256? Is it enough to generate 200 millisecond delay? 256. Okay, again, so this is 65.536 millisecond. Okay, again, not enough to generate 200 millisecond. What about 1024? 1024. Okay, so 1024 is 262.144 millisecond. Okay, so the maximum delay that can be generated by using 1024 prescale with a extra 1 megahertz is 262.144 millisecond, which is enough to generate 200 milliseconds. So in this question here, all right, so in these examples here, okay, we are going to use a 1024 prescale in order to generate 200 milliseconds. Okay, once you already decide what prescale that you're going to use, then after that, we do the calculation, okay, to calculate what is the TCNT value. Okay, so now, okay, you have a formula T equal to F over P, in which F is 1024, not F over P, P over F. Okay, 1024 divided with 1 megahertz, and then you will get, okay, you will get your T. So what is would be your T? T will equal to 1.024 millisecond. Okay, and then delay sama dengan T multiply by count. Okay, you have a T, and then you got a delay. Delay is 200 millisecond, and T is 10.24 millisecond. Then you will get count. Okay, so what would be the count? Count sama dengan delay 200 millisecond divided your T, 1024 milliseconds, and you will get how many counts? Sorry. 200 bahagi dengan 1.024 milliseconds. Okay, then you will get 195.3125. Okay, so we can simply use 195 or 196. Okay, so if you use a 195, means that the delay that you generate is smaller than 200 milliseconds. If you use a 196, means that the delay that you will generate is slightly longer than 200 millisecond. Okay, so once we already calculate the count, okay, so in this case, I use the 196 lah. Okay, the bigger value. Okay, I don't want to use the 195 because if 195, the delay is smaller than 200 millisecond because this pointing, we have this fractional number here. Okay, so I opt using 196. Okay, and then after that, okay, you can calculate your TCN. Okay, so TCNT equal to 255, which is FF, minus with 196 plus with 1, then you will get 256 tolak dengan 196, you will get 60. Okay, so this is the value that you're going to put to your TCNT. Okay, now we are going to write down the formula, the programs. Okay, so write a C program to toggle all bits of port B continuously. Okay, so now I just simply write here. Okay, so this is the program. Okay, so started with hashtag. Okay, we just write down the whole program lah, yeah. So include avr/io dot h. Okay, then after that, do you need to include any other files? Okay, we don't have to use the okay, in this example here, no interrupt required, so no need to include the interrupt.h file. Okay, then what about the timer? Okay, do you have any timer, what we call any timer header? No need to interrupt any timer header. Why? Because we use the timer programming, not use the timer function. Okay, so after you include this file, next what you're going to do? Okay, we're going to define the subroutine, okay, or initialize the subroutine to generate 200 millisecond. Okay, so you just simply void delay 200 ms void. Okay, define the delay 200 ms subroutine, and after that we started with our main program int main void. So inside of this int main void, what you're going to do inside here? Okay, first toggle port B continuously. Okay, port B means that, okay, make sure that DDRB we initialize it as a output port because you're going to toggle your port B. So the port B must initialize as a output port. And after you initialize your port B, is there any port that you're going to initialize? No, only port B, okay, as output. Then we start with while loop. Why while loop? Because you're going to toggle port B continuously. Okay, so inside of this while loop, what you're going to do here is, okay, first we send out 0 to port B. Okay, once you send 0, then you call the delay. Okay, so delay 200 millisecond, and then send again port B equal to OXFF. Okay, because this is 8-bit, it's saying that all the bits of port B means that you need to toggle all 8 bits inside of your port bits. That's why first I send 0, all the bit I give 0, and then after that, the next sequence I give all the bit 1. Okay, and then call another delay 200 millisecond. Okay, so this is the main program. Okay, now we're going to look at what we call here at our delay 200 millisecond subroutine. Okay, so void delay 200 ms subroutine. Okay, so what are we going to do? First step. What is the first step? Load the TCNT. Okay, so TCNT 0 equal to 0. 60. Okay, load the value that we already calculated earlier. Okay, and then second step. What is the second step? Anyone? Okay, do the Tccr setting lah. Okay, so in this case here, we are going to use normal mode. Okay, it's asking you to use a normal mode. Okay, and from this finding, okay, we need to use a prescale of 1024. Okay, so the value will be 0, 0, 0, 0, 0. And what is the value here? 1024. Prescale, anyone? 1024. Siapa nak tolong? Who going to help me? 1024. What is the prescale for 1024 for timer 0?
I think 101.
Okay, 101. Okay, correct. So 101. Okay, and then third step, what are you going to do for the third step? Okay, monitoring. What flag that you're going to monitor here? Okay, so since this is a timer 0, normal mode, so we're going to monitor TOV 0 flags. Okay, so while TIFR, okay, and with TOV 0, okay, is it equal to 0? If yes, it will keep monitoring. If not, so what happened here? We stop the timer. And after you stop the timer, then we clear the TOV 0 flag. So TIFR sama dengan, okay, put 1 to your TOV 0. Okay, so this is the delay 200 millisecond using timer 0 with a prescale of 1024. Okay, any question up until here? Okay, then you have another, any question before we go to another example, or we just skip this example here because this example already give you a solution and we go to this exercise. Ada soalan tak? Okay, if no question, okay then
Doctor, I have question, please.
Yes, Azari.
For internal external, doctor. Not...
internet external. Yes.
Yeah. So in this case, what's the instruction we follow?
Okay, in this case here, okay, because can you repeat your question again, Azari?
In case we use internal external like 1 megahertz. So the counter, what counter would we use?
Okay, so in this case, okay, if you're going to use a counter, okay, you cannot use the internal external. You cannot use the internal CPU speed. Okay, you need to have another external oscillator or external CPU external. Okay, internal CPU speed only used for delay programming. Okay, if you're going to make it as a counter, then you need to have another external connected to your T0, and then after that you can make it do the counter program.
Okay. Thank you, Doctor.
Okay, welcome. Okay. All right. Okay, so this slide here, okay, so this slide I just skip this one because it already give you the what we. Okay, so I'm going to focus look at this one because this is usually a timer one. Okay, so this is, for example, 940. I think you can follow this instruction. Okay, this solution here. Okay, now we're going to look at example 941. Okay, because this is a timer one programming. Okay, so write a C program to toggle on the port B pin number 4. Okay, so first draw the circuits. Okay, so you have port B pin number 4, PB4. Okay, you're going to toggle this bit here continuously every 2 milliseconds. So 2 milliseconds. Okay, use timer 1, normal mode, no prescaler to create the delay. Assume that the extra is 8 megahertz. Okay, so what are you going to do? Okay, you're going to delay a 2 millisecond delay, and it already stated that no prescaler need to use. Okay, so you can simply calculate what is the TCNT that you need to put to your timer, TCNT 1. Okay, so using the first equation, okay, which is T equal to 1 over F. Okay, so this one here, since F no prescale is used, so you can simply use the 8 megahertz. Okay, so 1 divided by 8 megahertz, and you will get okay, 0.125 microseconds. Okay, and then equation 2, which is delay equal to T multiplied by count. Okay, you know the T, you know the delay. Delay is 2 milliseconds. T is 0.125 microsecond. Then you can get your count. Count equivalent to -3, and then divided with T. Okay, then you will get what is the wait 0.12. Okay, 2 milliseconds divided with 0.00. So you need to have a 60,000 counts. Okay. Okay. So this one here, okay, since it is a 60-bit number, so I advise you to change to hexadecimal number first. 1000, and the decimal number will be, okay, so 3E80. Okay, so now after that, step number 3, TCNT1 equal to FFFF minus with count plus with 1. Okay, so FFFF minus count plus 1. Then you will get C180. Okay, so this is the TCNT. value. Okay, so in this case here, you can divide it into 2 bytes. One is a lower and the other one is high byte. Okay, now we're going to write down the program. Okay, the full program. Okay, we're going to write down the full program first, include the hash AVR file. Okay, next, you need to include any other header? No need. Okay, and then started with your initialize or define the timer subroutine. Okay, so void, let this one here timer 1 to ms. Okay, so this is the name of my subroutine. Okay, and then after that, I started with my main program. Okay, inside of the main program, so what I'm going to do, okay, make sure that, okay, I need to initialize port B pin number 4 as a output port. Okay, so DDRB, okay, simply make all the port as a output. Okay, and then there is no others port involved in this program, so start with while loop. Okay, so under this while loop, I need to do toggles to this port B pin number 4. Okay, so what I'm going to do here is first port B equal to 0B 0000 and 0000. Okay, so I send 0 first to PB4 and then call a delay. Sorry. Okay, timer 1 to ms. Okay, call the delay 2 millisecond and then toggle this port B pin number 4 to 1. Okay, and then call again my delay subroutine. Okay, so this is my main program. Okay, once you did that, then after that, we're going to write down the timer 1 to ms subroutine. Okay, so void timer 1 to ms subroutine. Okay, so under this timer 1 to ms subroutine, so what we're going to do? Okay, first thing first, because this is a normal mode. Okay, the first step here is you need to load the TCNT value. Okay, so TCNT1H and TCNT1L. Okay, so make sure that you load TCNT1 low and TCNT1H. Okay, the number that you need to put here is this number here, 80 to low. Okay, and C1 to your H. Okay, next, after that, what are we going to do? Right, after that, the second step, okay, your TCCR register, okay, do the setting. Okay, TCCR, since this is a timer one, okay, you have to, you know, set it at 2 locations, one at TCCR1A and the second one is TCCR1B. So the value here is 0 for default value for TCCR1A is 0. What about TCCR1B? Since this is a normal mode, okay, again, okay, we need to know lah which bit that we need to configure. Okay, do the setting. Right, this bit here, okay, for mode, and this bit to prescale. Okay, so 0B0000. Okay, because a normal mode, the value is 00 here. So 0000 and then followed by 00001. Okay, no prescale normal mode. Okay, and then next, After that, what are you going to do? Okay, monitor lah. Okay, monitor what flag? TOV1 flags. TIFR and with TOV1. Okay, is it equal to 0? Okay, what happens if yes? Okay, stop the timer. And after that, after you stop the timer, clear the TOV1 flags. Okay, so this is the solution in order to generate a square wave. Okay, with a delay of 200 milliseconds for each low and high logic levels. Okay, any question up until here? Ada soalan tak? Okay, if no soalan, I think okay we're going to look at this exercise. Okay, so this is taken from final exam. I think 2 semester back. Okay. Or no, this is the previous semester, if not mistaken. Okay, so the Atmega 32 is connected with a common ANET 7-segment display on port C. On reset, the system will continuously display character A to character F at a 1 second interval. Okay, timer 2 is used to implement the 250 millisecond delay. 2 function name delay and display will be developed in the system program. Use 1 MHz internal clock as your Atmega 32 clock source. Okay, so what you're going to do here is you're going to write a complete C program to have the prescribed property. Okay, show the calculation to generate a 250 millisecond delay using optimum prescale. Okay, you see here optimum prescale. Okay, so it means that you need to choose the prescale wisely. Okay. For example, if you're going to generate a 200 millisecond delay, okay, and by using for example by using a 256 or 256 prescaler is enough to generate this delay. Okay, so you need to choose 256 as your prescale. Okay, no, don't choose 1024. If you choose 1024, then your answer will be wrong. Even though 124 can accommodate to generate this delay here. Okay, so you need to make sure that, because in this question it says that choose the optimum prescale. Okay, means that you need to choose it wisely. Okay. And B, write the function name delay to implement the 1 second delay. And then write the function name display to display the character on the 7 segment. And write the main program that perform the required function of the Atmega 32 system using delay and display function appropriately. Total mark is 20 mark. So what you're going to do? Okay, so according to this what you call here question here, okay, you can draw okay your circuits. Okay, you have an Atmega 32 and then you have a port C, so this is a port C connected to common what is here, common ANET. Okay, what is a common ANET? All the ANET is connected to VCC. Okay, so you have common ANET 7-segment display connected to your port C. Okay, so this is 8-bit lah. Okay, on reset, the system will continuously display character A to F at 1 second interval. Okay, means that every time you reset, okay, and this 7 segment will display character A to F continuously with a 1 second interval for each of the characters. Okay, timer 2 is used to implement the 250 millisecond delay. Okay, so timer 2, okay, you're going to use a timer 2 to get a delay of 250 millisecond. Okay, and then two function named delay and display will be developed in the system. Use 1 megahertz. Okay, given that extra 1 megahertz. Okay, and then show the calculation generated. Okay, so let's assume that this one here use a normal mode. Okay, no, the one, is it a normal mode or? Okay, so let's change it. Okay, because we already always use the normal mode, or why not we use the CTC mode in this case? Okay, so CTC mode, timer 2, generate delay 250 millisecond, extra 1 megahertz. So now we are going to find out what is the optimum prescale. How to get an optimum prescale? Macam mana nak buat? Okay, before you proceed with the calculation. Okay, to calculate your TCNT, what you're going to do? Okay, you need to figure out what is the prescale that you're going to use in this program. Okay, since the delay is 200 millisecond, okay, and given that the extra is 1 megahertz, then what you need to do is you need to figure out the prescale because the prescale is not given. Okay, so you need to find out what are the optimum prescale. To get the optimum prescale, what you need to do is you need to make sure that what is the maximum delay that you can generate for each of the prescale option. Okay, so first, find is the max delay. How to get a max delay? To get a max delay, okay, you need to make sure that your TCNT value equal to 0. Okay, what happened when you put TCNT equal to 0? So this is the delay that you can generate. Okay, so since TCNT 0 and TCNT 2 equal to 0, so what happened? The count is sama dengan 256. Okay, so automatically you get the count value, which is 256. Okay, so based on this count value, then you can find out what is the max delay using the formula T multiplied with count, in which T equal to prescale over F. Okay, we already did this in the previous examples here. Okay, P over F equal to T. Okay, multiply with. Okay, so first, what are you going to do? Okay, no prescale. And then with a 8 prescaler. And then 16 prescale. Why 16? Okay, because timer 2, okay, have 6 prescale option. Okay, use timer 2, yeah. Where is our timer 2? Timer 1. Okay, you see here, not 16, 32 actually. Okay, salah. So timer 2, you have a 6 prescale option, 8, 32, 64, 128, 256, and 1024. Okay, mana tadi? So 8, 32, 64, 128, 256, and 1024. Okay, we're going to calculate what are the maximum delay for each of these prescale, and then after that we can decide which what prescale that we are going to use, the optimum prescale that we're going to use. Okay, so for the no prescale, what is the delay, maximum delay generate for no prescale? Anyone? Siapa nak tolong? Okay, 256 microsecond. Is it enough to generate 250 millisecond? Tak cukup. And what about 32? Okay, what would be the value? 8.192 millisecond. Also not enough. Okay, because you're going to generate 250 millisecond. Okay, what about 64? Okay, so this is a 16.384 millisecond. Also not enough. What about 124? Sorry, 128. Okay, 128 is 32.768 millisecond. Also not enough. 256. Okay, prescaler 256. There you get
65.536.
okay, millisecond. Also not enough to generate a 250 millisecond. What about 1024?
262.144.
Okay, 1024 is 262, yeah? 262.144 millisecond. Okay, so this one here is enough to generate 200 millisecond delay. Okay, so based on this comparison, okay, calculation, okay, you can see is that the optimum prescale that you can use is 262.144 millisecond. Okay, for example, okay, I give you another example. Okay, now you're going to generate a delay of 30 millisecond. Okay, what is the optimum prescale that you're going to use for 30 millisecond? Based on this calculation here. Is it 1024?
128.
128. So for the 30 millisecond, optimum prescale that you need to use or you need to choose is 128. If you use 1024, then your answer will be wrong. Okay, optimum is 128. So your calculation of your TCNT must use 128 prescale. Okay, so that is what by the meaning of optimum prescaler. Okay, so now we already choose the prescaler is 1024. So now we can do the calculation to find out what is the TCNT. Okay, so T sama dengan P over F, which is 1024 divided with 1 megahertz, and you will get 1024 millisecond. Is it? Betul tak? Okay. Okay, so this is the T. And then 2 delay equal to T multiplied by count. Okay, you already have the T 1.024 millisecond and delay 250 millisecond. There you can find out what is the count. Count equal to 250 millisecond divided with 1.024 millisecond, which is equivalent to 244.1406. Okay, so this is your count, 244.1406. Okay, since you have a fractional number here, why not we choose a 245? Okay, if you choose a 244, what happens? Okay, the delay you generate is not lower than 250 millisecond. Okay, if you choose a 245, okay, the delay is slightly greater than 250 seconds. So we choose a 25, 245. Okay, then step number 3. What is step number 3? What are you going to do? Not step number 3, equation number 3. Okay, since we are using the CTC mode, yeah. Okay, what is the CTC mode equation? OCR equal to TCNT, okay, plus with count minus 1. Okay, so TCNT always 0 for compare mesh. Okay, so the default value for TCNT is 0, plus with count with is 245 minus 1, then the answer will be 244. So this is your OCR 2. Okay, any question up until here? Ada soalan tak? Okay, if no question, then we go to write the program. Okay, so we have finished A. Okay, now we are going to do B. Write the function name delay to implement the 1 second delay. Okay, before we implement a 1 second delay, so what you're going to do is we need to do a 250 millisecond delay first. Okay, so void okay, open curly bracket and close curly bracket. Okay, so what you need to do? Okay, CTC mode. What is the first step of this CTC mode? Okay, clear the TCNT. Okay, so TCNT2 equal to 0. Okay, then after that, the second step, load your OCR. So OCR2 equal to what number? 244. Okay, after you load the OCR2 equal to 244, and step number 3, okay, TCCR2 setting. Okay, what would be the number for this TCCR2? Okay, so again, you need to know lah your TCCR2. Okay, which bit that you need to configure. Okay, which is bit 6 and bit 3. Okay, 0, 1. Okay, 0, 1 means that it is CTC mode. Okay, because we're using a CTC mode. What about prescale kat sini? What will be the prescale? Since the 1024, the prescale value is 1, 0, 1, 0, 1. Okay, so 0B 0, 0, 0, 0, 1, 1, 0, 1. Okay, if you have this value here, then you will get marks. Okay, next. Now we are going to monitor what value, what flags that you're going to monitor. Okay, since this is what we call here CTC mode, so we're going to monitor OCF2 flags. Okay, so Y, TIFR, and with. Okay, you just simply use this coding here, OCF2. Okay, is it sama dengan sorry is it sama dengan kosong? Okay, if yes, it will keep monitoring. If no, then what happen? Okay, stop timer 2. Okay, once you stop timer 2, then after that Okay, reset your LCF to flex. Okay, so this is a delay 200 millisecond. But in this question here, write the function name delay to implement a 1 second delay. So how to do a 1 second delay? Because this is only 250. Okay, you're going to implement the delay subroutine. How to do that? Macam mana nak buat? Anyone have an idea how to generate a 1 second delay? Because according to this timer 2, we only can generate up to 250 millisecond only. Okay, timer 2 not able to generate a 1 second delay. Okay, because the maximum delay that you can generate by using a timer 2 with a prescale of 1024 only up to 262.144 millisecond, which is not enough, okay, to generate a 1 second delay. So what are you going to do? Who have an idea here? Pardon, Azari?
We can use 254 times.
Okay, so you can call this delay here, this subroutine, how many times? 4 times. Or you can simply use a loop. Okay, do a 4 loops. Okay, so this one here, I just simply, okay, call it 4 times. Okay, so this is 200 millisecond delay. And then you call it once more. So now you already have 500 millisecond delay. Call again. Now you have 750 millisecond delay and calls once more. Now you already have 1000 millisecond delay, which is equal to 1 second. Okay, so this is your 1 second delay subroutine. Any question up until here?
Doctor, I have a question.
Yeah.
For this type of question,
Mm-mm.
you said we must find the 1 second, right?
Ya, betul.
1 second delay. So, do we need to write the delay 250 millisecond?
Yes, because in this question here, it asking you to use a timer too. Okay. Okay, just now, what we did is, okay, we tried to find out what is the maximum delay that can be generated by using a timer 2. Okay, the maximum is, even though we use it a 1024, the maximum delay that can be generated by using a timer 2 only up to 262 millisecond, which is not enough to generate a 1 second delay.
Oh, okay.
Okay, so that's why we need to generate a 250 millisecond first and then
then-
call it
okay.
4 times.
Okay.
Okay.
Thank you, Doctor.
Okay. Unless this question asking you to use a timer 1, of course lah, you can generate a 1 second delay. Because why? Because the timer 1, the TCR2 value is quite bigger. Okay, which is it support up until to 65,000 counts. Okay, so you can use a timer 1 to read. Okay, so no need to call it 4 times, something like this. All right, so now B is finished, and then now you're going to look at the C. Okay, write the function name display to display the character on the 7th segment. Okay, which is you're going to display A to F. Okay, so in this case here, before you do any program, what you're going to do here is you need to figure out what is the code A, B, C, D, E, F, okay, that you need to put in order, okay, to display character A, B, C, D, E, and F. Okay, since this one is a common ended, so common ended, what is a common ended? means that give all the NET is connected to VCC, okay, to turn on the 7 segment, okay, you need to give 0. Okay, for example, A. Okay, so this is your 7 segment. Okay, so to display A, what would be the value? So this is a A lah. Okay, so A, B, C, D, E, F, G, and H. Can you see this one ya? Boleh nampak tak sini? Okay, to display a A, okay, the LED that you need to turn on is A, B, C, E, F, and G. Okay, so now you're going to find out what are the value here. Okay, so A, B, C, D, E, F, G, and H. H is actually a decimal count, yeah? Your DP. Okay, so A, B, C, put 0 lah. Why put 0? Common. And okay, to turn on, you need to give 0. If you give 1, and A will turn off. Okay, so now we're going to, since to display A, B, C turn on, E, F, and G also turn on. What about the rest? Okay, you put 1. Okay, so what would be the value here? Which is 88. Okay, so you find this is 88, and then what is the C? Okay, the C you can do something like this. Oh, sorry, B. Okay, or you can simply something like this for B. Okay, if you choose this one here, what happen? All of the LEDs will be turned on except H. Okay, so the value here will be 80. Okay, then you find out the C. C is C6, D if C0, and then okay, so this one is 86 and this one is 8E. Okay, so you need to figure out this value here. Okay, after you figure out this value, then after that you can do okay C. Okay, now void display void. Okay, so under this one here, okay, you can use a while a for loop, okay, to display this thing, or you can send it line by line. Okay, so in this example here, I just send this value line by line in order to display this A, B, C, D, E, and F characters. Okay, so void display. Okay, the first character that you're going to display here is, what is the first character? A lah. Okay, so this A here, you need to send to what port? Port C. Okay, so just simply write port C equal to what value? To display A, 88. And then after that, what are you going to do? Call the delay. Okay, 1 second. Yeah, why 1 second? Because it already stated that, okay, each of this character, okay, interval is 1 second. Okay, so that's why we use the delay subroutine unit. Okay, because we're going to use a 1 second interval. Okay, so this is for A, and then you do it for B. Okay, OX80, and then call a delay. Okay, so this is a B, and then you do it until you send out okay, you display F. Okay, port C. Okay, what will be the value for the F? Okay, which is 8E. Betul tak? 8E. Okay, so this is the F. Okay, the value. Okay, so A, B, C, D, E, F, G. So A turn off, okay, on. B, C, D on, off. E, F, G on, which is a 0, 0, 0, and H also on. So you have 8, 7. Sorry, 8, 8. Okay, so this is 8, 1, 1, 1, 0 is E. Okay, correct. Okay, and call the 1 second delay. Okay, so this is to display F. Okay, and then after that, question D, write the, okay, what is the question D? Write the main program that perform the required function of Atmega 32 system using delay and display function appropriately. Okay, so you already do the delay and display. Okay, so now you're going to write down the full program. So this is A, B, and C, and this is a D. Okay, so for the full program, so what you're going to do here is, okay, so first include avr/io.h. Okay, and then you can define your CPU. Okay, because it already telling you that the CPU speed is 1 megahertz. Okay, you can define the CPU speed f underscore CPU. Okay, 1 million. Okay, and then after that, what you're going to do is, okay, this here, okay, initialize or define this delay subroutine. Okay, you have 1, 2, 3 subroutine. So void delay 250 millisecond void. Okay, and then void delay void, and then another one is void display void. And after that, you started with your main program. Okay, so what is the main program that you're going to put here? Okay, the main program here is, okay, you need to initialize your port C so that your port C become output port. So DDRC sama dengan OXFF. And after that, okay, is there any input output that you need to initialize? Okay, only port C. Okay, so next, while loop. Okay, under this while loop, what are you going to do? Okay, you call a display. Okay, so this display here is actually your main inside of your main program. So this is on your main program. Okay, include the header file, call all the subroutine that you already created earlier, and write your main program. Okay, that is, okay, so this is the solution for this question. Any question up until here? Any question? If no question, I think we'll stop here. Is there any question, guys?
For now, no, doctor.
Pardon?
For now, no, I don't.